Graphing inequalities can be done slightly differently from just looking at the graphs of two sides of the equations. The method in this video will mainly apply to linear graphs. So if you have linear equalities, for example, where one side is a linear equation and the other side is just a number, we can try a different way to see where the inequality region lies. So for example, if you have 3 minus 5x less than 10. So we want to see how to solve this. So it's easier to do it this way, especially if you're moving forward to what we call linear programming. So graphing such an inequality is what we're going to try and do. Our first step is to always graph the function as an equal. And then we determine which area to shade, whether below this graph or above this, below this line or above this line, and that's what we're going to do. But before we start with the actual graphing, it's good to understand what regions we're going to end up with. So if you graph inequalities, this is something that you could end up with, where, for example, in the first one, the unshaded region, so the unshaded is the inequality that would satisfy this graph. And sometimes the regions end up showing up because of a couple of inequalities, not just one equality. So it's not like me graphing just this. I've graphed a couple of inequalities, and because I've unshaded and shaded some regions, I ended up with this result. So for the first one, what we're going to practice now is just labeling the unshaded regions, which are the regions that your solutions are in. The first region is right here, just above the y equals to 1 horizontal line. And because it's dotted, we're not including 1, but we're looking at all the values above 1. So the region includes any value more than 1, but it also includes any value precisely less than 1. So we have two regions that are split. So either this region or this region, they satisfy the solution to whatever question it is. It seems a bit odd when we're doing this, but hopefully it's going to make sense with a few more examples. So with this one, we have many inequalities that have determined this boxed region. Let's look at the vertical sides first. So this is my x minus 2 equation, and this is my x equals to 2 equation, and I'm looking at all the x values between this negative 2 and 2 inclusive, so including those numbers. So my region of solutions, is any value less than or equal to 2 or greater than or equal to negative 2. And, so this time it's an and, it's not an or. An or is when the region is split, but when you're within the same region. So not only do the values have to be between negative 2 and 2, they have to be between those two y values as well. So this also encompasses the region. So y, so this is my y equals to negative 2, and this is my y equals to 3. So y has to be, this time it's a dotted line, so it's not included. Y has to be strictly less than 3 and strictly more than negative 2. So these two, only these two together, determine this box of a region. This is a combination. Now for the last one, we have a combination of a couple of lines. So let's break down the lines first. If you notice, nothing goes beyond the x-axis. So we have the y equals to 0 horizontal line here. We have y equals to 3. We have x equals to 4. And then we have this line, which in the next few examples that we're going to do, you're going to have to determine the equation of this line. But if something has passes through the origin, so it has a coordinate of 0, 0, and it has another coordinate of 5, 5, it means this equation is y equals to x, which is a common equation you'll find. So we have all of these different equations. Let's determine the inequality between all of them. Also notice how the shading doesn't go beyond the y-axis, so we also have x equals to 0 as one of our regions. So We can do it in any order, it doesn't matter. So let's look at the x values. So within this region, so just going vertical, or just looking at the horizontal values here, we need to be between 0 and 4 inclusive. So my region includes anything between 0 and 4. And then over here, looking at the y values, I have to be between 0 and 3, inclusive again. And in terms of the y equals to x line, I'm below the line. So if you notice, I have a relationship of y equals to x. Now it's either y bigger than x or bigger or equal to, or y less than or equal to x. So let's see. In this region, if I pick, let's say, 3, then any y value I pick here will always be less than 3, or it will be equal to 3. So my x will always be, so my y values will always be less than 3 in this case. So I actually have this situation. So if I take any of these x values, they will always be bigger than the y values I could get. So remember, we're not looking at the line, we're looking at regions here. Remember with the video regarding shading inequality regions. So we have this. We have y less than or equal to x. So these three determine the region here. So it seems a bit confusing as to, I'm saying region, but I'm looking at x, y, and x and y. So what values am I looking at? Well, I'm looking at coordinates. Basically, any point I pick here, the coordinate of this point will have an x value between 0 and 4. It will have a y value between 0 and 3. And at the same time, y will be less than or equal to x. So this is where the math gets a bit advanced, is you can actually pick values that satisfy a lot of inequalities, a lot of these conditions. And the reason you were able to do that is by shading the unwanted regions and then combining them together to see the only region left is the region that satisfies every single condition. So if you need to graph these, in a previous video you could graph this part, and then you graph a y equals to 4, and then you determine when's the line below this, and so on. Or you can solve it algebraically if you want to. But let's try and actually graph the region. So what you're going to do is, it's fairly simple for these questions. For each one, because the x and y are in this general form and it's not in the gradient intercept form, it's easy to graph them. What you're going to do is first make x equals to 0. So if my x is equal to 0, I'll have 2y less than or equal to 4, which means I'll have y is less than or equal to 2. So to graph this, you first have to graph this equation first, and my first step is to make x equals to 0, and if x is equal to 0, you can solve this. You're going to get y is equal to 2. So my first coordinate is 0, 2. And then you're going to make y equals to 0, and then you're going to solve it. You're going to get x is equal to 4. And now you have two coordinates, and you just draw a straight line through. So a straight line going through those. Now, how would you shade the region? It's by determining if 0, 0 lies in your region or satisfies the inequality or not. So does it satisfy the inequality? If it does, then 0 belongs in the region. If it doesn't, then you have to shade 0, 0 out. And that's the easiest way to shade those regions. So if I input 0 and 0 here, my answer is going to be 0, and 0 is less than or equal to 4, which means the 0, 0 coordinate belongs in my shaded region, which means this is the unwanted region. So I'm just going to shade this area. And I'm left with this as my region of solution. So this is my region, including all the any values here, 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 and the other quadrants. And we follow similarly here. I'm gonna let you do the maths where you, so this is just the x plus 2y equals to 4 line. I'm gonna let you substitute your 0 into x and then your 0 into y, and you're gonna get 5, you're gonna get 4.5. And this time we're not going to draw a straight line, we're going to draw a dotted line because it's a strict inequality, it's without an equal sign. So we have this line. And again, we do the test and we see if 0, 0 lies on the line. So if I substitute 0, 0, my answer is going to be 0, and 0 is not bigger than 5, which means 0, 0 does not belong in my region of solutions, which means I need to shade out this area. And the region of solution is going to be this, not including this line, because it's a strict inequality. It means that any value, any coordinates I pick here, any x and y I pick here, is going to satisfy this. If I substitute the x and y's that I picked in here, the answer is definitely going to be more than 5. This is what we're doing. And same thing here. If I pick any coordinate here and I substitute in here, it's going to be less than or equal to 4. And then for the last one, again, you need to graph. Remember, always label your lines. You need to graph this. The coordinates are going to be 0, 3, and 2, 0. And again, we have a strict inequality, so I'm going to graph a dotted line. And testing out 0, 0, if I substitute 0, 0 in here, it is going to be less than 6, which means 0, 0 belongs in my region. It means I need to shade the other side. So my region of solutions is here, and any value I pick in this region and substitute in here, it's going to be less than 6. So hopefully fairly easy. We've built all of these up. Now getting to the harder questions. So when we get to linear programming, this is the type of graph you'll end up with. But you'll only get up to here once you have the equations. Finding the equations, I'm going to leave it as practice to you. So I would recommend you pause the video and try and find it. I'll only give you hints for some of them, but then I'll tell you what I'm going to focus on is how to determine the inequality. So we have a y equals to 2. We don't have any vertical lines. This is y equals to x based on a few slides before, and this equation is whenever you see the x-intercept and the y-intercept having the same values, it's actually just x plus y equals to that value. So we have x plus y equals to 10. So we have 3 values here that have determined this region. So the region is, the inequalities that satisfy this region is y bigger than or equal to 2. We have in here for the y equals to x, notice that if you pick any values in here, they're always going to be less than your y. So we have y less than or equal to x. And for the x plus y equals to 10, you can look at the test we did in the previous slide, which is if I substitute 0, 0, 0, 0 won't work. Well, if you just look at the x plus 10 line without the other regions, it's clear that the x plus y equals to 10 line was shaded on the right side. So 0, 0 did belong in it. So we have that x, y plus x is less than or equal to 10. Let me explain this in a different way. Notice how if you pick any values here, let's say this was 5, or let's say 2, and then you'll pick, say here, a 5, you'll always have values less than 10. The only time you'll get values more than 10 is if you cross the line where it doesn't belong in the region. So you have to have values, all the values you're going to pick in here are going to be less than 10. And test it out by yourself. See the type of coordinates you could get here. And you'll notice that they're always less than or equal to 10. The only time it's going to be equal to 10 is if you're here, which is a 5 point. For the last one, we have a vertical line of x equals to 2. We have a horizontal line of y equals to 5. We have 2 linear lines that are not as clear as this line, nor this. So let me look at I'm going to call this the blue line. For the blue line, what you're going to do is just find the equation, and you should know how to find equations. So one of the coordinates is 0, 10, and then the other coordinate is 12, 0. And you can use any method to be able to find the equation. If you find the gradient and then you find the y-intercept, you're going to end up with this. And I'd rather have it as a where x and y are on one side. So I'm going to move the 10. And then I'm going to multiply by 6 on both sides, so I'm going to end up 6 multiplying with this whole thing. So it's going to be 6y minus 60. And then I'm gonna keep the x and y on one side and then move the constant to the other side. So I'm going to have 5x plus 6y equals to 60. So that's the equation of this line. And then you can use the same method for the other line. The coordinates are 0, 0, and 15 and 5. For the other line, you're going to get y equals to 1 over 3x. And for this line, we have that it's equal to 5x plus 6y equals to 60. Now, what are the inequalities? So going through each one, we have, for the vertical, we have that it's all the values bigger than 2. So x is bigger than or equal to 2. For the horizontal line, so that was the vertical. For horizontal line, we have everything less than 5. So we have y is less than or equal to 5. For the blue line, we have it's all the values below this line. So we have 5x plus 6y is less than or equal to 60. And you can test out values as well, as I mentioned. If you pick any coordinate in this region, so obviously any value you're going to pick here is going to be less than 12 and less than 10. So anything less than 12 and less than 10 times 5 and times 6 will always give you something less than 60. So just pick any random value here. And if you pick any value here, say, just pick any coordinates of, say, 11 and, so we're looking at this line. So we have 11 and 12, or 11 and 8, say, and test them out, substitute them in here, you will get something bigger than 60. So the region is always something below than 60. And then we have the red line, and same concept. You can try and substitute values. Obviously 0, 0 won't work in substituting in here, but you can test out different numbers and you'll notice that it's always y is bigger than or equal to 1 over 3x. So all of these as a combination will give you those shaded regions. A bit of a complicated example, but this is what you'll end up with basically in the end, and you'll need those regions for linear programming.